All right, here's some help for numbers 8 and 9 on your proof worksheet number 2. Let's take a look at number 8. We're given that the measure of angle 1 is equal to the measure of angle 3. And what we want to prove is that 2 and 3 are supplementary. Okay, so this proof, the whole thing's blank. I'm going to give you some hints for some of it and then expect you to be able to finish it. If you don't have your blue sheet, you might want to pause the video right now and grab that blue sheet because it will be very helpful. All right, so let's start with number 8. If you have no idea what else to do, always start with the given. We are given that the measure of angle 1, whoops, let me fix that. The measure of, The measure of angle 3 is equal to the measure of angle 1. All right, why can we say that's true? Because we are assuming that it's true. All right, the word we use to say we are assuming this to be true is we just say given. So let's just say that the measure of angle 1 is equal to the measure of angle 3 is equal to the measure of angle 1, and then from that we can prove that 2 and 3 are supplementary. All right, now I want you to take a look at angles 1 and 2 in the diagram. Notice that they are adjacent. Notice that their non-common sides form a straight angle or a straight line. All right, so if they are adjacent and their non-common sides form a straight line, then they satisfy the definition of a linear pair. So we're going to say that angle 1 and angle 2 form a linear pair. All right, and we can back that up with the definition of linear pair. If you look on your blue sheet at the definition of linear pair, it says two angles form a linear pair if and only if they are adjacent and if their non-common sides form opposite angle or opposite rays, which is what we have going on here. All right, now also look on your blue sheet at your linear pair theorem, which says if two angles form a linear pair, then we may conclude that they are supplementary. Well, we have two angles that form a linear pair. So we can say that angle 1 and angle 2 are supplementary, and what justifies that is the theorem that we proved in class called the linear pair theorem, which says if two angles form a linear pair, then we may conclude that they are supplementary. Now, if you look at your blue sheet, look at the definition of supplementary angles. If we say that two angles are supplementary, we may conclude that their measures add up to 180. So we're going to say that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And the reason why? Definition of supplementary angles. I'll let you fill that in. And then let me give you some hints for the rest of this. Take a look at step 1 where we said that the measure of 3 and the measure of 1 were the same. All right, so if the measure of 3 and the measure of 1 are the same, then I can take step 4 and rewrite it, except I'm going to replace the measure of angle 1 with what it's equal to. Instead of writing the measure of angle 1 here, I'm going to replace it with the measure of angle 3 because they are the one and the same. So if you would rewrite that, and the reason, remember, if two things are equal, the reason I can replace one with the other is the substitution property. And then once we have said in step 5 that the measure of angle 3 plus the measure of angle 2 add up to 180, then your last step will be to say that they are supplementary. Angle 3 and angle 2 are supplementary, and you can back it up with the definition of supplementary angles. All right, so you might want to pause the video right now and finish number 8. And then we're going to move on to number 9. Okay, number 9, what are we given? We were given that angle RPS, that's this angle right here, RPS, is congruent to angle TPQ. So I'm going to put one arc on RPS, and then I'm going to put one arc on angle TPQ because we are given that those two angles are congruent to each other. So given that, we're going to prove that angle RPQ is congruent to angle TPS. All right, so you'll kind of notice as you look at this diagram that the two angles that we're given are congruent, have this overlapping part, okay? What we're going to prove congruent, I'm just going to shade in the two angles that we're proving congruent, okay? We're going to prove that angle RPQ and angle TPS are congruent to each other. Okay, so that's where we're headed with this. All right, so now let's start. If you have no idea where to start, a good place to start is with the given. We are given that angle RPS is congruent to angle TPQ. I'm not very good at this, air slate. Give me 1 second. I'm going to adjust something. All right, now, why do we know that's true? Because we said so, that's why. We're assuming that it's true. Let's just say that angle RPS is congruent to angle TPQ. We say that in one word by writing given for our justification. Now, if they are congruent, okay, then if you look at your blue sheet at the definition of congruent angles, it says two angles are congruent if and only if their measures are equal. So I can say that the measure of angle RPS is equal to the measure of angle TPQ, and what justifies that is the definition of congruent angles. Okay. All right, now let's take a look back at the diagram, and I want you to notice that this angle RPS, okay, the first one in our given statement, okay, RPS is made up of two angles, isn't it? The measure of RPS is equal to the sum of its parts, the measure of this smaller angle, RPQ, and the angle that hasn't been shaded in, QPS. So I'm going to take a step to say that. I'm going to pause the video while I write that. All right, you might want to pause the video to catch up with me. So we have the measure of angle RPS is equal to the sum of its parts, the measure of angle RPQ plus the measure of angle QPS. Now, that is a postulate that we've known for a while now called the angle addition postulate. Now, keep in mind we have a segment addition postulate. Don't get the two mixed up. One of them has to do with angles, one has to do with segments. This one clearly is dealing with angles. Now, the same thing can be true about our other angle in the given statement, that TPQ, the whole thing, is equal to the sum of its parts. So we're going to say that the measure of angle TPQ is equal to the sum of its parts. That would be the measure of the white angle, angle QPS, plus the measure of angle, the other part, SPT. Now that reason is the same as for angle addition postulate. All right, I'm going to do one more step with you and then just give you some hints for the rest of it. I want you to look back at step 2, where we said that the measure of angle RPS was the same as the measure of angle TPQ. Now, in step 3, the measure of angle RPS is equal to this sum, right? And in step 4, it says the measure of angle TPQ is equal to this sum. So what I'm going to do is I'm going to rewrite step 2, but instead of putting the measure of angle RPS, I'm going to put what it's equal to, which would be, and I'm going to have to squeeze this in here, the measure, prepare to write small, measure of angle RPQ plus the measure of angle QPS is equal to, now again, what did I just do? I replaced the measure of RPS with what it's equal to. Now, I'm going to rewrite the measure of angle TPQ and put what it is equal to, which is the sum of these two angles. So that would be the measure of angle QPS plus the measure of angle, I'm just going to have to squeeze this in here, SPT. There's an S right there on top of that 5. Okay, now what did I just do? I took step 2, I replaced the measure of RPS with what it is equal to, which is this sum. I replaced the measure of angle TPQ with what it is equal to, which is this sum, so I just use the substitution property of equality. Okay, now look at the picture. Do you see how the two angles that we marked congruent to begin with have this overlapping white angle, angle QPS? And look over here in this great big long statement. Do you see how I have a measure of QPS on the left side of the equal sign and a measure of angle QPS on the right side of the equal sign? So what I can do now is I can subtract that from both sides. I would be subtracting the same measure from both sides. So if I had two things equal to begin with and I subtract the same amount from both sides, the left side will still be equal to the right. Your reason will be subtraction property of equality. And then I'm going to leave it up to you to figure out step 7. It's pretty easy. All right, if you have any further questions, be sure and ask me in class tomorrow. And I hope this has been helpful.